All right, this has been up for a little while, but if you just got here, take a minute or two to go through these warm-up problems real quick. We'll do them. We'll finish up 2.6. I'm gonna do 1.4 with you today. We're not gonna be tested on 1.4. You're gonna hate 1.4 unless you're crazy. I was gonna say a freak, but I know like some very non-freaky people that like fucking 1.4. I am not one of them. All right, who can help me with the trig derivatives? Go for it, Matthew.
Cosine of x.
I assume you're going down the left side.
Negative sine of x. Secant squared of x. Want to keep going?
Someone's got to go.
Negative cosecant times cotangent. Back.
You know what? I do that too. I eliminate saying the argument, saying the x. I do it all the time. Go for it.
Let's see if I can secant of x times tangent. And then that one's cosecant squared x.
Close.
Is it negative?
It's negative. Those are all correct. Hopefully you should have those memorized. Definitely, you will see these all the time, and you'll see secant x quite frequently. Cosecant and cotangent are like the redheaded stepchildren of fucking trigonometry. No one wants them around. No, that's fucked up. There's got to be a redheaded stepchild in one of my classes. It's the black sheep of the family. We never use it. All right, so next problem is find the first and second derivative of f of x equals x cubed cosine x. Who wants to give me a gander on this one? Are we gonna make Matthew do it again?
I'll do it.
All right, Matthew, hit me with it.
So f prime of x, I got negative 3 times sine of x.
That's what you got? Anybody else get that? That's incorrect. Now, let's break it up and what's going on. What do we have here? I have x cubed and I have it multiplied by cosine of x. Now, this is definitely, when we do this one, that's going to give us the negative sine x that Matthew had. And I'm guessing the 3 came from doing the power rule on the x. But there's more going on there. This is a product rule. Yeah. You want to try again?
Maybe. Sure. So it'd be 3 times cosine plus negative Sine of X times.
It's not 3 times cosine. You're missing something on this. You're going too fast.
I am.
Yeah. The power comes down and the power drops by a power. That's 3x squared. Because the derivative of that one's 3x squared. So 3x squared cosine x. And then that's, so we're doing a prime b plus a b prime. So we did a prime b and now we need plus a. I'm calling that a and that's my b. A is x cubed and b prime is negative sine x. So maybe I'll rewrite that where I don't have a plus and a minus. That's the first derivative. Now, second derivative. So I need to do, and I'll write it out here, being a little bit more clear as I go. It'll take a little bit longer to write it, but it might help you remember what we're doing. That's the first term's derivative. And then I have minus, I'll do this all in parentheses or big bracket here. We're going to do x cubed prime sine x plus x cubed sine x prime. I haven't taken the derivative yet. I just write it out, make sure we don't miss it. All right. So what do we get here? The derivative of 3x squared is 6x. The derivative of cosine x is, wait, I got it up there, negative sine x. And then I've got minus derivative of x cubed is 3. We actually, this is what we started, well, almost what we started with up there. 3x squared, and then we got the sine x there. Then I'm going to transfer the minus here, do the minus, distributing it to both of these. Minus x cubed cosine x. And I'm not going to leave it like that. I'm going to clean it up a little bit. This doesn't have anything in common with it. The middle two do. They both have x squared sine x. I've got a -3 here and a -3 here, which makes -6 x squared sine x. And then finally, the minus x cubed cosine x. So that's kind of a refresher on the trig derivatives and product rule. What's the formula for quotient rule? Yeah. Or did I fuck something up?
Formula, but I had a question. So since f prime had essentially two products, 3x squared times cosine of x, what we did was we did product rule individually for those two terms.
Yes.
Oh, okay. Just double checking.
Yeah, they are separate terms because of that minus sign right there. So we treat them separately. We're taking the derivative. Like when we go to the next derivative here, we're doing derivative of that. But the minus sign makes it so we can do it as the derivative of each. And then when we do the derivative of each of these, that turns into the products.
Gotcha.
All right, what's my quotient rule?
Low D high minus high D low.
Low D high minus high D low over low squared. The other way is doing exactly like we did with the product rule. Where we have high prime low minus high low prime. So it's got the same format, high coming first over low squared. The D here is representing derivative. So you'll see that those two are the same. I learned it as low D high minus high D low over low squared, but after having recognized that it's exactly like the fucking product rule on top with a minus sign instead, I very much like that. In fact, seeing that shows me better the connection between it and the chain rule / quotient rule, or the product rule put together, as we're going to do in the last problem. You'll see what I'm talking about in a second. All right, before we get jumping into finishing up 2.6, a couple things. I got an email last night by a student asking where the homework problems are. I hope to God in future classes, you don't wait until like 5 weeks into the class to ask where the homework is. I've got them listed at the beginning of each chapter right after my lecture notes. So chapter 1 homework problems are there. Chapter 2 homework problems are here. I just sent out an announcement this morning for a practice exam posted. I will be covering how to do this practice exam on Thursday class. That's our Thursday class. If you can, if you've been like fucking me and you're super rock star in your homework, staying caught up, you're probably on 2.5 right now. Try to get 2.5 and 2.6 done, and then try this practice exam before coming to class on Thursday if you can, because then you'll know exactly where you're struggling. As soon as I go over the problems, you will have seen them once, and it's going to be somewhere in the back burner. So if you try to get it done before then, you'll have a better feel. Next Tuesday is our exam. Here, in person, you got to be here. I will be here. I pledge you I will get here by 7 a.m. In case anybody's like, I want more time, you can fucking come in and work from 7 a.m. till 10. Okay? You don't have to be here at 7 a.m. You can fucking stroll in at 9 a.m. if you want. If you think you can get the test done in an hour, yeah. 12. For 2 hours, that's like 10 minutes a question. It took me I didn't time it, but it was very low. There's like 10 to 15 minutes to go through the problems and solve them all. So if I can do it in 10 to 15 minutes, you should hopefully be able to do it in an hour or an hour and a half, definitely 2 hours, if you've been doing your homework and stuff like that. On Saturday, I will be in the Mesa Center over in Visalia from 9 to 12. The only people that have come to it from this class, the only people that have come to it, period, are from this class. Cynthia and Sensi have been showing up. Show up and ask questions. Cynthia, how many questions do you actually have to ask me when you've been there? You don't ask that many questions.
I do.
In an hour, you might ask 3 questions. You're over there working on your homework. She's using it as a spot to work on her homework, and then ask me questions when she gets stuck. You don't have to walk in with a list of questions to ask. You can work on your homework there. Okay? It's free. We don't have to pay for anything. The advertisement says there's going to be a light breakfast available, but I didn't see a light breakfast available, and I wasn't asked to bring a light breakfast, so I don't know what the fuck that's about. I gotta ask the Mesa department when we do it. But test on Tuesday. Okay? Next Tuesday. let's get popping on finishing up 2.6. 2.6, we're on, I'll say B because this is our second time doing it. This is the chain rule one. So this is where we have, if we have an f of x and a g of x, and we evaluate f at g of x, and we want to take the derivative, it works inward. The derivative starts off hitting the f, and then the next step, the derivative travels inside the parentheses. So then we have d dx of g of x. A common way that this is treated is a handy way, is we can call g of x u, call it some variable, and this becomes d dx of f of u. Maybe using f and u doesn't, I hear it. I hear it when I say it out loud. Doesn't sound like the best letters. So this will be f prime of u, but u is a function of x. It's u equals g of x, so then we have to do the derivative of that. Then we got to do du dx. I guess maybe I should stick with the same fucking notation and do u prime like that. We got to have something at the end with respect to the variable that we're starting with. As a reminder, that letter on bottom tells us what the variable that we're taking the derivative with. Derivative with respect to x. All right, so let's look at some examples.
Hey, Neil,
Yeah,
I had a question.
fire away.
I was looking at 2.6, the homework, and the first question was fog, parentheses fog. How does that tie into, is that the same?
So fog x like this is a, and I hate this, is a short, I'm going to use quotes, shortcut for f of g of x.
Oh, so it's just different notation.
Yes.
Okay.
How many characters are they actually saving by writing this? We have the F's, we have the G's. I have parentheses like that. I have inner parentheses like that. And then I have an X. This fog, using fog, it actually takes more work. It's got one more character. It's not a fucking shortcut. It actually takes longer to write fog X. What jackass in mathematics thought this was a fucking good idea? I don't know. It actually takes longer to use the notation people like to use. All right. Maybe I should start on the page. Make sure we got room to write. Anyone need that up longer? I can lift it. There we go. Let's take the derivative with respect to t of y equals sine of cosine of 2t minus 5. So until you're comfortable busting this out quickly, I would write out what you're doing each time. So the first thing I gotta do is take the derivative of the whole thing. I'm taking the derivative of that. Then I move inwards. And the next thing inside is cosine. So next I'm taking the derivative of cosine of 2t minus 5. And then I move inwards again. Inside the argument of the trig function, now I need to do 2t minus 5 derivative. So I keep moving inside the function. Maybe I should put ddt over here too. I hit the sign, then I hit the next thing, then I hit the next thing inside. I keep working inward. What's the derivative of sine? Cosine. So this green one is cosine, and the inside just stays the same. What's the derivative of sine? Derivative of cosine?
Negative sign.
Negative sign. And the inside stays the same. What's the derivative of 2t minus 5 with respect to t? 2. Change colors. So dy dt equals I'll put the 2 up front, and I'll put the negative up front. -2. Maybe I'll put the sign first because it doesn't look like a fucking Frankenstein of a trig function. And then I've got cosine of 2t minus 5. And that would be the answer. I'm going to go back up here and show this using the substitution. I'm going to say u equals 2t minus 5. So this becomes sine of cosine of u. And then I'm going to say cosine of u, let's use w, because v's can look like u's really quickly. W equals cosine of u. So this just becomes sine of w. So when I take the derivative of this, I need this is the derivative of the sine times dw dt. So we've got sine w, the derivative is cosine w. And dw dt is cosine of u. It's not in terms of t, it's in terms of u, but u is a function of t, so we gotta do it again. Derivative of cosine is negative sine. So this is negative sine of u times du dt now. And so that ends up being cosine w times negative sine of u. And the derivative of du dt is 2. And now you go and you start plugging shit in. Because we didn't start with W or U, we're not gonna end with W or U. So cosine of W is cosine of W is cosine of U, and U was 2t minus 5. So I'm just plugging it in. That's my first part. The negative sine U is negative sine of 2t minus 5. And I think the 2 is easy to see. And now we're back to that line right there, and you just multiply it out, or you rearrange it to clean up how it looks. Any questions? I'm okay with you using either approach, whichever way is more like intuitive for you to follow. Some people really like the substitution method. I know I did. When I was first learning it, I liked substitution a lot. And I outgrew it. I got good, I got better at seeing what was going on. With practice, you get better at everything. Hopefully. Right? All right, you guys ready for more? A little bit longer? Okay. Good. Okay. I'm going to give you guys a few minutes to work on this next one. We want to take the derivative with respect to x of f of x, where that means taking the derivative of tangent squared embedded with secant cubed t. Now, I will point out, I'll rearrange it because a lot of people forget how that notation looks. That is the derivative with respect to x. The tangent, the square on the tangent is actually outside the tangent. And then we have sine cubed of t, and then the inside. That means the cube is on sine t like that. I need another one. Yeah, there we go. I was missing a bracket. So these go together, then that goes together, and then the parentheses are like that. So you start on the outside, you gotta do the square first, then the tangent. And then we're inside the tangent, we're on the cube. And keep going. This is way harder than anything on the test. There's a lot of steps here, right? Just take your time. If it helps, I'll put up our little warm-up derivatives of trig functions. You might find it easier to do substitution, make u equal sine t cubed. That way you've just got tangent u squared, and that gives you a smaller chain rule to do it first. And then when you get to the u, you switch over to doing sine t cubed. And feel free to talk to each other. You guys are too fucking quiet. Pause recording while you guys are working on it. Give you guys like 5 minutes. Okay, I'm gonna go very slowly. The first thing I need to deal with is the square. So this is a power rule situation. So the first step is to bring the 2 down and lower the power by 1. So it goes down to 1. So I'll have 2 times tangent of sine cube t. Now I gotta go inside that, and now I'm gonna hit the tangent. And the derivative of tangent is secant squared. So we're gonna have secant squared times what's inside, sine cube t. And then I gotta go inside the tangent. And inside the tangent is the cube. So 3, I bring the 3 down, I lower by a power, and I get 2 up top. I will have 3 sine squared. Wait, what am I doing? Yeah, 3 sine squared t. And now I gotta take the derivative of sine. I'm moving inside. And the derivative of sine is cosine. How many of you got that far? Good work. Did you go one more step? We gotta go inside the trig function. dt dx. That's the final piece right there. Time is not a function of position. dt dx equals 0. Time t is not a function of position. So when f of x equals tangent squared sine cube t, dt, or the derivative with respect to t of f of x is 0. Who's like, yeah, fuck that guy? It's a little sneaky, right? Pay attention for this. F is a function of x. Nothing says that x is a function of t. All right, so. It's not sharing what I want it to. There we go. So the big takeaway was of this thing, this is like, since says a t and this function is in terms of x, these are all constant in terms of x, just like 2 or an 8. So when we take the derivative with respect to x, it's just like having an x is 0. And if you did the power rule on the 0, you bring the 0 down and it zeroes it out. The derivative with respect to a constant is 0. It's one of the first derivatives we learned. Yes, Matthew.
So I guess just equals 0, but I was wanting to get cleared up. Like which terms we did the derivatives of, like kind of in terms of substitution. Because I'm not tracking where, at what point we did dt of d of x.
Okay, so.
I just want to know.
Oh, okay. After we did the cube, we go inside the cube and we do sine next. And after we do the sine, we go inside of sine. And we have t.
Okay.
That's an excellent question. The big takeaway is if it says it's a function of the letter and you don't see the letter, like you see a different letter, this letter is assumed to be a constant. Let me write this on the next page. Like if I called this g of t, if I said g of t was tangent squared sine cubed of t. This looks like what I'm saying is f of x equals g of t. And if you say take the derivative with respect to x, this is fine. This becomes g prime of t dt dx. Unless the problem, unless something explicitly tells you you or us that t is a function of x, we have to assume it isn't. And by assuming it isn't, we're saying t is a constant with respect to x. The derivative of a constant is a 0. Now, if you worked through and did all that stuff, you still got a lot of good practice in doing the chain rule. So I just threw a little sneak attack in at the end as a way of like making sure like you'll never forget this. If you work through this problem and you're, well, hopefully you never forget this, you'll pay attention to look for the letter. Does this make sense right here? If they're different letters, you gotta like, we can't just assume that it's otherwise. The way we would know t is a function of x is they might say one way to show it, to show t is a function of x, they might just give us this equation. T equals 2x plus 3. Gives us an equation. That's one way. They might also say t equals h of x. That's another way without giving us an explicit equation. Well, the equation's there, but without knowing what it is in terms of x. That's neat. I'm quite pleased with myself. I will have you know. You guys ready for more? Wait, because people are still writing this. All right. Next problem. Find y double prime. If you see that, just assume it's in terms of the letter that's present. Of sine of 3x squared. Oh, wait. Find what will y double prime if sine of 3x squared equals y. There we go. So y equals sine of 3x squared. The first derivative is we're going to take the derivative of sine, which is cosine. We leave the inside alone, but then we take the derivative of it. So 3x squared, the derivative is 6x. So we have a 6x here. And that looks bad, so I'm going to put the 6x in front. That's y prime. All right, next one. Oh, we got a product rule with the chain rule. We got two parts, don't we? We have the 6x and we have the cosine 3x squared, which means we got to do a product rule. So I'm going to be a little bit more explicit before I do this next one because it's complicated. We're going to do 6x, we're going to take the derivative of that one, and we're going to leave the cosine 3x squared alone. And then we're going to leave the 6x alone, and we're going to take the derivative of cosine 3x squared there, and that's going to have the chain rule in it. Y'all with me? First part's not too bad. Just drop the x. The derivative with respect to x is just 1. So we've got 6 cosine 3x squared. Then I've got plus 6x. Now I've got the derivative of cosine is negative sine. And I have the 3x squared in there. And then I got to do the derivative inside the 3x squared, which we already said was 6x. Nope, minus. There's a minus. I've got 2 6's, so 36. I've got 2 x's, so x squared. Kind of messy. It's ugly looking, right? But ugly doesn't mean wrong. Well, unless it's an in-law, and then it does. All right, next thing. You guys ready for more? I'm gonna do it in general first. If we've got like our function is high over low, our quotient. F prime is high prime low minus low high prime or minus high low prime all over low squared. How did they come up with that fucking formula? That seems fucking excessively complicated, right? Let's check out the general version of this. I'm going to write this as H and then L to the -1. You know, when we move it to the other side of the fraction, we give it a negative exponent. Same thing as 1 over x equals x to the -1. Or 1 over x squared is x to the -2. We move to the other side. And so now if you take the derivative here, we got to do product rule. So we're going to have h prime L to the -1 plus h and then L to the -1 prime. So that's h prime over L plus h, we bring the power down, is -1. And then we've got L, we lower it by a power, is -2. So I rewrite that. This is minus h over L squared. But I didn't finish the chain rule, my bad. We take the derivative of L to the -1, but the -1 is an exponent on the L. We also still need an L prime. I didn't finish, my bad. And get a common denominator. We have the derivative is h prime L minus h L prime over L squared. The entire point of telling you this was, we're going to use this on the next problem. This shows you where the quotient rule came from, and it also shows us we don't need to use the quotient rule. Right? The quotient rule is derived from doing the product rule with the chain rule. So while people are still writing that down, let me write down the next problem. F of t equals t squared minus 1 over t cubed plus 1. We actually did this very problem in 2.4 using the quotient rule. Try it using product rule and chain rule. like rewrite it as t squared minus 1 times t cubed plus 1 to the negative 1. And go from there. I'll give you a couple minutes and try to work this out. It's good practice. It's good enough. I'll tell you this right now. There's 2 questions on the test. Both questions have the same function. One question says, do this using the quotient rule. The other question says, do this using the product and chain rule. So you can, on the test, you'll be able to verify that you got the same answer on both. But knowing both methods is pretty fucking helpful. And it gives me a means of testing you on quotient rule, product rule, and chain rule. All in 2 questions. Sorry about Zoom going off earlier, folks. The internet shut down for like 2 minutes. And just like at some point during this general form, I had to get a common denominator, you're probably gonna have to do the same thing too. Done already, V? Did you give up on me? You did it? You tired? What do you think about it? Okay. 30 seconds. We'll go through it. Try one more method that you guys might like for chain rule or product rule. Or both. Let's call that A and let's call that B, all of it. So that the derivative is going to be A prime B plus A B prime. And then do them separately. Like, don't try to do it all at once. Go, okay, we know what A and B are. I need to find A prime and B prime. So let's do A prime. If A is t squared minus 1, A prime, I take the derivative, it's just 2t. And I got B equals t cubed plus 1 to the negative 1. When I do the derivative, I need to do the chain rule. So the negative 1 comes down and the power drops by 1. And then I need to take the derivative of the inside, which is 3t squared. So this would be my f prime of t. When I put that all together, f prime of t equals a prime, which is 2t, times b, which is t cubed plus 1 to the negative 1. And I have plus a, which is t squared minus 1, times b prime. I can clean this up a little bit. I can make this negative 3t squared times t cubed plus 1 to the negative 2. Where I just put the negative 1 and the 3t squared together. So a prime b plus a b prime. Now let's get rid of the negative exponents. I've got 2t over t cubed plus 1. And then I've got minus 3t squared times t squared minus 1 all over t cubed plus 1 squared. So I'll get a common denominator by multiplying this by t cubed plus 1 over t cubed plus 1. And now the top will look like high prime low minus low high low prime. If you've done that, I'm just going to start trying to clean it up. 2t to the 4th plus 2t minus 3t to the 4th plus 3t squared. Looks like some stuff combines on top. Got a negative t to the 4th. I wonder if that actually factors on top. No, that negative sign is throwing it off. There's no way. I mean, we could take out a T, but. All right, you guys ready for the ugly? Oh, yeah. Since you're gonna see the answer in the other form, you should get them to match. Ideally, you are combining it where you have one numerator like this without a bunch of parentheses, because you want to see if it factors and cancels anything on bottom. Any other questions? Okay. So when you take the power down, you've got to lower it by a power. So like x to the minus 1, we bring the power down, and then we do -1 minus 1. So that's where we get the negative x to the -2. I'm going to hit stop recording and make a second video for the next part.